this chapter, we're going to talk about conic sections and parabolas. Now, there's a whole bunch to read in this 8.1 conic sections and parabolas. As you can see, the first 3 pages deal with all the reading and talking about all the different types of conic sections that we have. A couple of things we need to talk about, though, after you read about the conic section. They can be defined algebraically as a graphs of second-degree quadratic equations in 2 variables. So this is going to be our standard form of a conic section. ax squared plus bxy plus cy squared plus dx plus dy plus f equals 0. Again, we're going to be going through a lot of this stuff later in this chapter. We talk about a parabola. Now, definition of a parabola. Parabola is the set of all points in a plane equidistant from a particular line, which is called the directrix, and a particular point called the focus in the plane. Now, the line passing through the focus and perpendicular to the directrix is called the focal axis. The axis is the line of symmetry for the parabola. The point where the parabola intersects its axis is the vertex of the parabola. The vertex is located midway between the focus and the directrix and is the point of the parabola that is closest to both the focus and the directrix. So as you can see here, the distance from the parabola to the directrix and the distance from the parabola to the focus is going to be the same. And also the distance from the focus to the vertex and the vertex to the directrix is also going to be the same length. Okay, no matter where we choose this point on the parabola, it's going to be the same. Now we can generalize the situation expression 1 to show that an equation for the parabola focus 0p and directrix y equals negative p is x squared equals 4py. Now the big thing that we need to see here, with x squared equals 4py, that x squared, it opens up and down. The directrix is going to be opposite of where the focus is going to be. Now, and then we're going to have a standard form here show that a point is on the parabola. All this mathematics, okay? The big thing that we need to remember, the focal width is going to be the value 4p. So that's going to be the width of the parabola from the focus. That's a nice, easy way to draw your parabola. Now, since x squared opens up and down, y squared will open left and right. Now, again, I told you about the 4p. Well, if we make vertical lines here, the focal width will be 4p. So when we draw that, this will be the 2p, and that'll be the 2p, like the 2p. So that's when we draw that. If p is bigger than 0, then it's going to open to the right or up. If it's less than 0, it's going to open to the left or down. Now, we do have a chart here. Parabola is the vertex 0, 0. The standard equation, we have x squared equals 4py, y squared equals 4py. Now, if it's x squared, it's going to open up and down. If it's y squared, it's going to open left and right. Then we have the focus, directrix, axis, focal length, and focal width. Now, I have that same chart here, so we can go through example 1 together. Now, we need to find the focus, directrix, and focal width of the parabola. Since it's y equals negative 1/2 x squared, we need to do some manipulations here to make it look like our standard equation. Well, in order to do that, we need to get a positive x squared here. So I'm going to multiply both sides by negative 2. So negative 2y is equal to x squared. So what we're going to have here, this is going to open up and down. 4p will equal negative 2 because x squared is equal to 4py. That means p will equal negative 1/2. So since p is equal to negative 1/2, my focus, try writing that again. My focus focus will be 0p, so 0, negative 1/2. My directrix will be y equals negative 1/2, which is 1/2. And my focal width is 4p, that will be 2. And again, it's the absolute value of negative 2, so that's why it is 2. For letter B, x squared equals 6y. 4p is equal to 6. That means p is equal to 3 over 2. My focus, because it's x squared is equal to 6y, that means I'm going to use my left side of this chart here. My focus will be at 0p, so 0, 3/2. My directrix will be a line, y equals negative 3/2. And my focal width will equal the absolute value of 4p, which is 6. So there we have it. Focus, directrix, and focal width of the parabola. Now in example 2, we're going to be actually creating an equation in standard form for the parabola that satisfies the given conditions. So here's what we're going to have. Our directrix is x equals 2. Our focus is 2, 0. So because of that, because it's x, we're going to use the right-hand side of our column here. Okay? So that means my p-value will be 2. That should help us a little bit. Now it's going to be y squared is equal to 4py, or 4px rather. This should actually be changed to an x here. So make sure you make that change in your chart. So because it's y squared is equal to 4px, I'll have y squared is equal to 4 times 2x, which means y squared is equal to 8x. There is my equation. Oh, let's actually make a change here too. This focus should read negative 2, 0. So p-value is going to be negative 2, which means this will be a negative 8x here. I apologize. Now if we look at B, it says focus is 0, 5, directrix is y equals negative 5. So because the directrix is y equals negative 5, we're going to use the left-hand side of our column, x squared equals 4py. Our p-value is 5. This should make it nice and easy. Our p-value comes from right here. So x squared is equal to 20y. That will be my equation. Now in this next video, we're going to talk about translations of parabolas. As you should know by now in mathematics, not everything's going to be centered at the origin. We're going to move things around a little bit. Now when a parabola, the equation x squared equals 4py or y squared equals 4px is translated horizontally by h units and vertically by k units, the vertex of the parabola is moved from 0, 0 to hk. Such a translation does not change the focal length, the focal width, or the direction the parabola opens. It's just going to change where the vertex is. It's also going to change our focus and the equation of the directrix. Okay? So again, here's a chart that we can use to help us figure these things out. So example 3, find the equation in standard form for the parabola that satisfies the given conditions. Well, the vertex is 3, 4. That means h equals 3, k equals 4. Now, it does give us our focus of 5, 4. Well, if you notice, the k value does not change. That means we're going to be using this part of the chart here with h plus p is equal to 5. That means 3 plus p is equal to 5. which means P is equal to 2. Once we find that, we should have no trouble at all creating our equation. So we're going to have the y minus k squared equals 4p times x minus h. Now you should also notice that k is always going to be with y, h is always going to be with x. Now when we plug this in, we'll have y minus 4 quantity squared equals 4 times p, which is 8, x minus 3. There is your equation. Now for b, our focus is negative 5, 3. Our vertex is negative 5, 6. That means h equals negative 5, k equals 6. And if you notice here, the negative 5 is still the same as this. So we're actually going to use the left-hand side of our equation because that's the part that changes. The k plus p changes. That means k plus p is equal to 3. 6 plus p is equal to 3. That means p is actually equal to negative 3. And we're going to use the equation x minus h squared equals 4p times y minus k. Well, now that we found p, now that we found h and k, we can actually plug this into our equation. X minus negative 5 will be x plus 5 squared is equal to 4 times negative 3, which is negative 12, times y minus 6. Here's your equation that fits